Thanks for coming out to our session today. We're here to talk about debugging serverless for the cloud, which is really going to be talking about our new Java support that we have in Azure Functions and all the great VS Code tooling we've been working on to make that just feel nice and snazzy. I'm Chris Anderson. I am one of the developers that works on Azure Functions. I work on the infrastructure for managing all the languages. This is Xiaokai. He's a PM on the Java tooling team who's helped us build the Java support for Azure Functions.
Hi, everyone.
So I like to start this off always kind of talking about why serverless. Serverless is a very new concept still in kind of the age of computing. And I always find it's really great to kind of ground the discussion for what we're talking about in the context of why serverless is innovative. So before the cloud, you basically had all the problems of having to get everything structured on premises. I've got lots and lots and lots of questions. And I always equate questions to friction. And the more friction that we've got, the less agility we have as a business unit to deliver new value. So as a general rule, I'd say we want to reduce questions, reduce options, and focus on just the parts which actually deliver that unique value. So here we've got lots of these issues, totally unstructured. And then the cloud comes in there with IaaS, and there's still lots of questions, but it becomes a bit more structured because you're limited by what the IaaS provider has, but they do a lot of upfront work for you in terms of choosing hardware, having that hardware provisioned ahead of time, et cetera. But of course, these are still a lot of questions, and they're all still very focused on servers. We don't find ourselves really thinking about the applications and putting the applications first. And so we really need to find a way of shrinking that down just even a little bit further. And so then enters PaaS. And this has been great because PaaS still allows me to lift and shift existing server workloads up onto the cloud without having to manage them, without having to update my OSs, et cetera. But in terms of building out new functionality, PaaS still forces me to think in that server mindset. I'm still required to think about how many resources do I need? How is it going to scale when I get that burst traffic on Black Friday? All of these things that come from infrastructure questions still have to be kind of top of mind. And so serverless finally goes through there and basically says, you know what? We'll solve having to think about servers by killing servers, hence the name of servers. I should say that it's serverless, but there are still servers. They're just not yours. I call it serverless. I don't like the name a whole lot, to be honest, but I call it serverless because you think about servers less. And that's the whole notion of serverless, is that you're going to basically be thinking about how do I write individual components that all will go ahead and scale completely independently, and it's designed out of the box to do it. You can't build a monolith on serverless. It's by default little tiny chunks that all freely scale independent of each other. And so that allows me, even though I did that, to still focus on a lot of very common scenarios. I can do real-time streaming where every single time that I get a new message that comes from a factory floor device, let's say that it's still sending up some old 1980s binary format. But all of my analytics processing expects JSON or some other CSV format that it's going to go out and do its processing on. I can have a function which takes that binary format and converts that to JSON on every single message. And at night, when the factory's turned off, if that should be the case, the infrastructure all scales down, and I'm only paying when the factory's actually up. If the factory increases the amount of throughput that it's trying to put through there and I've got more messages to process, it'll scale up to meet that demand. And I'm only paying for what is basically being produced there. And of course, we have things that are not happening in response to real-time events. Timers based off of batching or some kind of business schedule is still an incredibly common thing for us to go do. Let's say that I've got data that I'm soft deleting every time the user requests something to be deleted. And thanks to all the various regulations out there in terms of user privacy, I've got to make sure it's all gone within 30 days after the user requests for it to be deleted. I can have a timer that's running on a regular basis, which goes through there and does that delete operation for me. And it'll all be expressed by just a single function or a logic app or something along those lines, which runs in response to a timer event, treating time as the event in that case. Once again, when that timer job isn't running, if it doesn't need to be cleaning up a database or something like that, you're not having to pay for the infrastructure that that timer is going to be running on. It's only there when that job is being run once a day. So no more dedicated infrastructure and trying to pack them full of cron jobs to try to get the most efficiency out of your cron system. And then, of course, we're going to have apps. I can still go ahead and write apps using functions or any kind of serverless technology out there. They can still support HTTP. I can still do RESTful services. I'm just generally expressing those RESTful services as a collection of functions. But I can still have those collections of functions represent an API surface area. It can still do HTTP just as I normally would if I had a server. So I can do all those same scenarios, return HTML, build a mobile app, all those types of experiences. And then I like to talk about bots, because bots are really kind of this next wave of interactions. We have got our normal mobile apps and our web apps, and this is the way that we've been doing things for the last couple of years. But bots are this new interaction that we've got with users, where we expect all these various interfaces out there, be it on someone's Slack channel or on some consumer's Facebook messaging feed. I want to do bots. And thanks to things like the Microsoft Bot Framework, I can write a single function to react to a particular event that happens in my bot. And it'll work on Slack, Facebook, Teams, whatever it should be, it'll work through that bot interface. And I can express those actions as functions or logic apps. And so the way that we do that, the way that we solve those scenarios on Azure at the very least, which is what we're going to be talking a bit about today, is using functions, which is code-based serverless. So I can run code in response to an event. And we also have a technology, we're not going to be talking about it as much here because it's a shorter talk, but if you find me at the booth, I'll go ahead and tell you about it. And it's logic apps, which is a workflow that runs in based to an event. So that's, you basically have codeful serverless and no code serverless. But they can also work together, so I can have a logic app which calls a function and vice versa, so they can interact with each other. But that's not sufficient to build an application, of course. That's obviously just making decisions in response to events. You need to have something which delivers the events in terms of messaging. You need to have a place to store the data that interacts with it outside of that. And you have managed services on Azure like Cosmos DB to deal with that. And of course, you need other services like intelligence, cognitive services to do text analytics or face recognition, et cetera. That all work comes out of the box as well. So none of those things require any infrastructure being spun up to host those services. They're all managed services that already exist on the platform. And this is important because as soon as you introduce infrastructure back into your application, while some parts might be serverless and you're still getting those benefits, your organization is still going to be kind of dragged down and anchored to that infrastructure. And so it's something to be cognizant of, is that you try to reduce infrastructure where you can in dependencies to get the best advantage out of serverless. And of course, when you're building anything, developing anything, it requires developer tooling. And that's actually going to be kind of the rest of what the talk is focused on, is all the great tooling that we've been building to try to make Java great inside of VS Code, and then tie that into our Java support for Azure Functions. So even though we've killed your servers, you can still have all the normal tooling that you would have done if you were building normal server-based applications. So on that, I'll hand it off to Xiaokai.
Thank you, Chris. So exactly 2 months ago, during Java conference, we announced the Java support for Azure Functions right here in the same conference. So today, actually, after 2 months of the new service being available for the public preview, we have hundreds of developers using our new service. We also have lots of feedback and questions coming along. So with those helps, we actually have the new serverless Java support today to demonstrate to you. So we actually have more features, such as better HTTP support, better documentation. We also have better tooling. So for example, today we're going to show you the better integration for serverless Java with VS Code, as well as the new remote debugging functionality. So, sorry, it's not working.
Someone's radio is stepping on our radio.
Oh, fun.
Yeah, so.
It sounded like it was cutting out a bit, but I'm not sure up here whether or not that's actually happening. There we go.
Okay. Oh, it's better. Is that better now? Cool, thank you. So with that, we actually have more broader tooling support. It's not just VS Code. We also have tooling support for IntelliJ Eclipse, which are the IDEs you love and like. We also have all the plugins for Maven, as well as CI/CD support within Jenkins. And for your diagnostics usage, you can use App Insight, which is a homegrown service with Azure, or use your own diagnostic tools. With that, let's put more fun in functions.
What's more fun than a demo?
Yeah. So it's not mirroring. I don't know.
You might need to escape out.
Yeah.
Yeah.
So, OK. So here what I'm showing you is a simple HTTP function. You can see that it's from annotation, it's take a HTTP trigger. So wherever HTTP request coming through, it will take it as a trigger and input. And what it does is very simple. So you can see it from here. It takes the query string and the body, and it's trying to see what kind of input is there. And after getting the input, it's called the sort function, sort method. Sorry, here's an issue with my code. So you can see with the Java support in VS Code, it's actually reporting the code issues just as what you will see in other IDEs. So if I click on this, there will be a light bulb here, and I click on this and say, okay, you can change it to sort function. So basically, I can correct my code to match with my method here. But actually, what I want to do before was actually to rename this symbol to do some, to get it a better name, maybe bubble sort here. So as you would expect from an IDE, so when doing this rename, the method here will be renamed as well. So this is just a quick feature of the Java support we have within VS Code. So now we have the code ready, right? So what we want to do is do some unit test to make sure the code actually runs as what we want. So we have some code test case here, and you can see we have with our JUnit test plugin, it already have those code lengths for you for running and debugging those tests. So we can simply click those, and it will run the test and show you whether the test goes through or not. And you can expect the same IntelliSense linting features within VS Code as well as what you have seen from other IDEs. So after testing those local methods, what we want to do is probably to check whether the function behaves correctly as we expected. With Azure Function, you actually have the local emulator within the call tool shipped cross-platform. So you can install the function call tool through npm, but later on we'll also ship it with other methods which is more native to your platform. So I have already this call to install locally. What I'm going to do is to try to load my function locally and test it. So with the Azure Function extension here with VS Code, it already wired those all up for me. The only thing I need to do is to hit F5. Let me just do that. So what it will do is use our Maven plugin to build and package the function, and build the jar file and the configurations, and then it will launch the function local runtime to find this jar file and load this function locally, so we can test it locally against the HTTP trigger. So you see it's now actually building the function. So while it's building, we can further take a look at the code. So actually, you can see with the HTTP trigger, you have those metadata for this trigger all supported by our IntelliSense, by the class path already. So when you're writing those functions, you don't really need to think about how I configure the trigger, how I connect with other endpoints. Those things are all figured out for you. So you can see the function is already loaded, and we already attached to it for debugging. So when you're working with HTTP endpoints, they're always a lot of fun. You can use whatever tools you want. But for me, I always want to stick within my editor. So I just have another extension for the HTTP endpoint. So let me show you this. So this is my HTTP request. So I've installed another extension in VS Code called REST Client, which can help me call the HTTP endpoint directly from the editor. So you can see through code length, I can send requests here. And in the window on the right, it tells me, oops, there's an issue. Please pass a list on the query stream. So what's wrong with that? We probably want to debug it. So I will set a breakpoint here. A second, close this. And run it again. See, the breakpoint has been hit. So you can see within VS Code, there's also a very native debugging view. You can see your local variables. You can also watch your variables. You can step through as what you would expect. There are also Debug Console. So with this debugger, we're also shipping more advanced feature very soon, such as hot code replacement and expression evaluations. So let's just try step through. The query here is none. What's the problem? Then I see that here the query string is actually expecting list, but what I sent was list. So probably this is the problem. I just change this and let the original one run through, and I try to hit this endpoint again. So this time it should work correctly. Yes, and so you can see it returns the sorted list as what we were expecting. So with all this fun locally, the next step probably we'll want to deploy to cloud and see how these things works on the cloud, right? So let's just discharge this, stop the local runtime, and try to deploy to Azure. So what you will see here is actually we're still using the same Azure function extension. So previously, during Java, when we used the Maven plugin to deploy to Azure, as you can do on every terminal or bash window. So with the extension, it makes things much more easier. So you just click the deploy to Azure, choose wherever folder your function is written in, choose the Azure subscription, and choose wherever the endpoint, the function you want to deploy to. So the deployment will take a while because I need to package the function again and upload to the Azure runtime. What we want to show you is so after it's uploaded, it's running on Azure, you can also attach to the remote runtime and debug it locally. So let's try to do this. So for remote debugging, let's see. For remote debugging, we have built a tool for that, and this tool also running cross-platform. And so the reason we don't build this remote debugging tool into the VS Code extension for now is because we want this tool to be usable for also like users using Eclipse IntelliJ with other debuggers you like and love. So see, here's a simple instruction for using this tool. We just need to put the fully qualified name for the function.
Actually, I was the one who had to build the feature, the server-side feature support for this particular one. And the first time I saw it working in VS Code was like this morning, because I've been doing everything in IntelliJ. So it works great in the other editors just as well. I like that it's got the VS Code integration now, though.
So once we click this, so this tool will also very easily find so once you give it your fully qualified name, it will figure out which subscription the code is running in and which application the code is running in, and it will automatically attach that for you. So you can see now it's having the correct SH terminal open and ask me to connect to the port on my local host. So actually, I already have a debug configuration for that attaching to this local host, and let's just run it. So as you would expect for remote debugging, it takes some time for attaching. Oh, it's actually working. So it's attached to that, and let me send a HTTP request to that remote debugging again. So the remote URL is this one, right? It's my remote app on Azure. Just send request.
And I think it hit it because you're.
No, this should be fine. Just send. Let's see. Yeah, probably I will send a request from the crew. Oh, it's hit. So as you can see, probably the Wi-Fi problems just take much longer than I expected. So now you can see the breakpoint has been hit. And we can also step through just as what we're doing locally. Now it's much faster. And to show you how it works for the debugging, I think you all know that we can maybe edit some values here. So just some, and run it through. So it should give me the response with the newly entered numbers. You see that. So this is how the remote debugging works. It's attached to the remote process running on Azure. And you can, so even if your serverless function is already deployed, you can still debug it locally. So what I've showed you is how you can easily create, develop, and debug function locally, as well as deploy and then debug it remotely, all within VS Code, our IDE for polyglot developers, as well as have very good support for Java. So you can also see here is the extensions I installed. As I said, VS Code is very much extendable editor. So I have the extensions here for some of the Azure extensions like Azure Functions. I also have a bunch of Java extensions installed. For example, Debug for Java is created by Microsoft. The language support for Java is done by Red Hat with collaboration with us. And there are also Spring Boot extensions so delivered by a Pivotal team, and we are working with them to bring better Spring Boot support in VS Code as well. So with that, I'm going to wrap up with the demo.
one thing I'll add in there is a lot of the stuff that we showed you, even the debugging tool underneath the covers, is actually open source on GitHub if you're curious to follow along with what we did there. The debugger is actually really cool because it's basically proxying the Java debugging protocol over WebSockets to our instance that's actually running up there on Azure, and then we're opening up that debug port on Azure as soon as those connections come in there. So there's some latency to set up that connection because it's being proxied through WebSockets. But I mean, the actual code to make that work that's on GitHub is actually really fun to read through if any of you are curious later.
Yeah, we'll surely want to encourage you to all join us on the GitHub, give us feedbacks. So those are the links available for the tools and the materials we demoed just now. And if we want to take a deeper look at the code, you can see that it's just simple Java POJO. There's really no much secret in that. With that is a single HTTP functions. We do actually also support a lot of other triggers and bindings. So basically, you can trigger your function, as Chris mentioned, use a timer for your scheduler job, and you can get input, output from all the storage options. And those are all supported out of box. So we also build extension models, so you can extend the function to connect to any third-party service or Microsoft service. So you can see we have Event Hub, like Cosmos DB for NoSQL database, and you can also build your own triggers and bindings for your own third-party service. We already have some samples with SMS and email sending protocols.
That's using SendGrid and Twilio. So we're able to talk to those services using just bindings rather than having to bring in their SDKs.
Yeah, so there's an additional slide talking about VS Code. I've already shown you the extensions available today. If you want to try VS Code on your Java code base, please give it a try. As Ergama also mentioned in the first day's keynotes, it's really a lightweight editor. It's fast, and it's so we actually consider it's like first, if you do like a lot of polyglot development, you're also working on different languages. VS Code will give you a more immersed experience in that. So please give it a try. So with that, I will go hand back to Chris to talk about more on Azure functions.
We're just going to skip to the end of that animation there. It's funny how we talk about building apps faster, but then the animation just seems super slow. So I'm an engineer, not a PowerPoint guru, I guess. So basically just want to kind of really hit on the fact that what we've tried to do here with all of the tools, all the services that we're building, everything that we're trying to do both inside of Azure Functions, but also as a cloud as a whole, is oriented towards trying to increase just speed of delivery. I've seen in my kind of time working on Functions since we started it, a lot of interesting cases where we had customers come in and think it was going to take traditional cycle of it'll take us 6 months to build out this prototype, and we're really looking forward to working with you over that time. And I'd kind of nod like, yeah, I'm sure it'll take 6 months. And they'd come back in a week, and they'd have already had their prototype done, because a lot of that time that they had factored into things was the time to provision infrastructure, the time to provision VMs, the time to ramp developers up on that technology. When it really comes down to just writing some functions and maybe a logic app to glue them together, you can move as quick as basically you can write the code down. There's not any infrastructure there to manage. There's no infrastructure to figure out how to scale the thing. And so you can really just focus on, what I as a developer like to do, which is just kind of write the code. The rest of it kind of comes later. It really just works thanks to the services and the experiences that we're building. And thanks to the VS Code stuff, we've been able to do some really nice integration with the rest of the VS Code tooling for Azure. But of course, we are also building all that stuff to work on the IDEs you might be familiar with, like IntelliJ and Eclipse. And I've been using IntelliJ for like the last year that we've been building this. And it's really been nice to see it get better literally month by month as we do new releases internally for ourselves. So I'm really happy with that experience. So with that, if you want to learn more, you can go ahead and start with AKMS/Java-serverless. That's a link to the VS Code extension, which I think is the fastest way to get started. You can also go to functions.azure.com if you want to learn more about functions in general. There's also a serverless landing page, which I'm sure I could have another marketing link for, but you can find it if you go to azure.com.
Yeah, and to add, don't worry if you don't have an Azure account right now. So with this tutorial, you can start without an Azure account, and then when you want to deploy to Azure, you can create a free account with $200 credit as well. So
yeah, and it's also got 12 months of like always free services beyond the $200 of like the not always free services. So everything you can really imagine you'd have a chance to do as long as it's using like the serverless type things. Spinning up a giant HD Insight cluster will probably go through your spend a lot faster. And then just to call out, there is one more session by Asir actually, who's in the audience. Tomorrow, he's going to be talking about the development workflow of using some of the tools we've been doing to deploy Spring apps. So definitely check that out tomorrow if you're still around. And then for anyone who wants to, you can go back and check out the recordings. Definitely check out Eric Gama's keynote. We've also had a couple of other really great sessions about things we're doing at Microsoft to improve developers' lives. So we open for questions now. I think we timed it right, so we had about 5 minutes. And then otherwise, thank you for coming.
Thank you. Yeah, please.
Question?
Have you done much like serverless actually in, like beyond POC, but like actually in production at scale?
So yeah, that's a great question. So the question was essentially, do we see folks doing serverless at production at scale? Just to give you a sense, I had a fun call before I came here, so on Monday, where we had a customer burst from like 100,000 requests a day to like 3 billion in a day. And that's actually not, the number itself actually wasn't super interesting. We have people who are run at 3 billion a day, quite a few of them, but just the fact that they burst that much, that was the first time we'd seen someone burst so quickly. And so that was particularly cool. So in general, we're seeing people run things at large scale. We're seeing them running in a production steady state load. So we've seen quite a few cases both for high and low demand there, yeah.
And so I guess my question within that is kind of it's like functions, like moving from monolith to maybe like a little service-oriented to microservices. Kind of with that, you know, the smaller deployables have kind of created, you know, complexity in networking and in pipes, and functions are going even farther. So kind of from that additional jump, like what kind of issues have you guys run into from that?
I actually did a talk at a Serverless Conf that was in New York City back in October. It kind of gets to some of those points. What we did when we took away your servers is we also got rid of a lot of your existing best practices that you developed using servers. And some of those things can still apply as at least analogies, but the tools that were built for those best practices are only starting to come around. So it's still very nascent. There's lots of opportunity to improve things inside of the serverless community. But as a general rule, what we've done and where we've seen people do things currently is they're generally operating against cloud-managed resources. So as opposed to having to spin up their own infrastructure, they're using the existing cloud resources. And then you don't have to necessarily figure out how the things glue together. Since it's just Azure talking to Azure, we know how to glue those things together. And we see that in general across serverless. We can build a more intelligent services because you're using this very controlled environment. We can optimize it for talking to the rest of the cloud as opposed to you having to do that work for you. But there's lots of room, especially in the microservices space. I generally say that functions still today, a function app, which is a collection of functions, is a microservice. There is still plenty of work to do in the space to actually add the S to the end of that, so you can have microservices. We have a case study that is out now from Fujitsu, where they actually built their own little microservices kind of ecosystem using a lot of existing tools like, I think VSTS or something like that at the time, but Jenkins is a good equivalent there. You know, they can still build those things like the way they had to do for IaaS or before on premises, but we haven't yet gotten to a guided experience. I think in the next year or two, you'll see us really try to keep on reaching down to build more and more complex apps without you having to figure that out every single time. We don't like seeing people repeat themselves if we can.
Yeah, and as Chris mentioned, we deeply engage with customers and learn from customers as well. So with the new version of the Java function, we also update our document with best practice, how you should use serverless within like Azure Cloud. Yeah. So lots of things are also new learnings to us as well.
Yeah, definitely if you've used Java on any of the other serverless platforms, definitely take a look at least at Azure Functions. We've done some interesting things there by using the attribute model to actually express what your function entry points are, because it allows you to actually write a class with many, many functions in them, all with their entry points, and then we manage the packaging behind the scenes for how to distribute those things. And so even though they're individual functions, it feels like you're writing an application. So you're abstracted away from the infrastructure of even the functions themselves. We handle that for you via tooling.
So I assume you can add security to those services, right?
Yeah, so the security is always an interesting thing because there's lots of different, security is layers, right? So it's really about which layers are you responsible for still in the serverless world. Obviously, you're no longer required to make sure that the OS is patched. We do that. Antivirus is running. We do that. We do things like hardening the ports to make sure that there's no exposed ports that are inappropriate, et cetera. Out of the box, HTTP functions are hidden behind API keys, and you have to go through there and actually expose them to the internet as anonymous. We have the ability to go and throw them all behind a central authentication provider for you if you'd like to. And then otherwise, it's just normal security best practices of making sure that developers aren't allowed to deploy the code to production themselves. So use some kind of CI service to validate that this was a approved build that's going to production. But a lot of the infrastructure security is designed to be taken care of for you yourself. There's some amount of application security in terms of identity management and authentication that you still need to participate in, but we've done a little bit to help if it aligns with what you want to do. It doesn't always align because we can't solve every problem in authentication. And then when it comes to developer best practices and security, it's still kind of up to you. We haven't gone out there and tried to change the way that you do deployments to always make them secure. It's still on you to do those best practices.
So assume that you can do authentication and authorization as well, just what any other microservice.
Yeah, like for instance, one of the things that's very easy if you wanted to is you can use Active Directory and just slap that in front of your whole function app, and then any requests that come through will automatically force you to sign in with AAD, and we automatically redirect you to the AAD sign-in flow. And that's really great if you're building like an internal business application or just a private version of your site. Let's say you've got like a beta stamp or something like that. You just throw that in front of it, and then everyone's forced to go through that flow, sign in with their AAD, and go forward. That doesn't work for like external customer-facing apps as much, but it works great for internal applications. And we've got like Facebook, Google, and Twitter authentication if those are what you want to use. But I want to add GitHub soon because I do a lot of just GitHub authentication-based sites. Anything else? Hopefully we're on time there. So thank you for coming out. If you have more questions, feel free to stop by the booth. We'll be there for the rest of the night because we're on booth duty now, I think. So
Thank you for coming.
thank you, everyone.